Okay, let's see one more example on finding the eigenvalues and eigenvector for the matrices. Okay, given the matrix A equal to 1, 2, 3, 0, 4, 5, 0, 0, 6. So this matrix A is a 3 times 3 matrix. Okay, let's say I assume that this column is belongs to the variable X, variable Y, and variable Z. You can also use x1, x2, and x3. It depends on you because this one is unknown variable, so you can use any variable. Okay, so question asks us to find all the eigenvalues of A. So first we need to find the eigenvalues of the matrix A. And question number 2, find the eigenvector correspond to the largest eigenvalue. So you can have, or you will have, more than one eigenvalues. So the question number 2 asks you to find eigenvector just for the largest eigenvalue. So we will find the eigenvalues and we will see which one is the largest one, and we will find the corresponding eigenvector for that eigenvalue. Okay, so let's proceed with finding the eigenvalues of A first. So the first step to find the eigenvalues, okay, is by computing the A minus lambda I. Okay, where lambda later will be the value of your eigenvalues. Okay, so now we have 3 times 3 matrix. Therefore, your lambda I will become lambda 0, 0, 0, lambda 0, 0, 0, lambda, where it is the value of lambda multiplied by the identity matrix of 3 times 3 matrix. Okay, so now A minus lambda I will give you the matrix A, which is 1, 0, 0, 2, 4, 0, 3, 5, 6. Okay, minus with lambda I is lambda 0, 0, 0, lambda 0, 0, 0, lambda. So what you will have is 1 minus lambda, 1 minus lambda, 2 minus 0 is 2, 3 minus 0 is 3, 0 minus 0 is 0, 4 minus lambda is 4 minus lambda, 5 minus 0 is 5, 0 minus 0 is 0, 0 minus 0 is 0, 6 minus lambda is 6 minus lambda. So this is the matrix A minus lambda I. Okay, step number 2, you need to find the determinant of A minus lambda I. Means that you need to find the determinant of matrix 1 minus lambda 2, 3, 0, 4 minus lambda, 5, 0, 0, 6 minus lambda. So we have learned before how to find determinant for 3 times 3 matrix, where one of the method is to copy the first 2 column outside of the box. Okay, so let's copy these 2 column outside. So what you will have here is, so let's copy this one and put it outside. Okay, so you will have these 2 column outside of the box. Okay, so how to find determinant of 3 times 3 matrix? You need to put 2 bracket and in between is the minus sign. So the first bracket, you need to multiply the diagonal element here, 1, 2, and 3. Okay, so now you need to multiply 1 minus lambda times with 4 minus lambda times with 6 minus lambda plus with 2 times 5 is 10, 10 times 0 is 0, plus with 3 times 0 is 0, 0 times 0 is 0. So that one is for the first column. For the first bracket. For the second bracket, you need to multiply from here, from the bottom to the top. Okay, all element here. So you have 0 multiplied by this one is 0, 0 multiplied with 3 is 0, plus 0 multiplied with 5 is 0, multiplied with this one is 0 as well, plus this one multiplied with 0, multiplied with this one will give you 0. Okay, so what you have for determinant of A minus lambda I you will have only this one. So the determinant of A minus lambda I is equal to 1 minus lambda multiplied by 4 minus lambda multiplied by 6 minus lambda. Because this one plus with 0, you will get the same thing. Minus with 0 will give you the same thing. Okay, so next, to find the value of lambda, we need to assume, or we need to let the determinant of A minus lambda I equal to 0. So now you have this one as determinant of A minus lambda I. So let's write it as 1 minus lambda, 4 minus lambda, 6 minus lambda equal to 0. Therefore, from here, you can see that you have 3 value of lambda, 1, 2, 3. Okay, so from here, you will get your first lambda equal to 1, your second lambda equal to 4, your third lambda is equal to 6. If you ask me how I get this one, so you just take this one and let it to be equal to 0. So you will have 6 minus lambda equal to 0. Then you bring negative lambda to the right, you will have 6 equal to positive lambda. So you have lambda equal to 6. So same goes to this one and this one as well. Okay, so now you already have your lambda 1, lambda 2 and lambda 3. Therefore, this one is your eigenvalues. Okay, so now we already have all values of our eigenvalues, which is 1, 4 and 6. And if you see the question number 2, the question asks us to find eigenvector correspond to the largest eigenvalue. Means that we need to find the eigenvector for eigenvalue equal to 6, because this one is the largest one. And you need to be careful because question only asks you to find eigenvector, not normal eigenvector. Okay, so you just need to find eigenvector. So how to find eigenvector correspond to this eigenvalue equal to 6? We just need to compute A minus lambda I, where now we already know the value of lambda is equal to 6. Therefore, we just need to compute A minus 6I. So the matrix A is equal to 1, 2, 3, 0, 4, 5. So you have 1, 2, 3, 0, 4, 5, 0, 0, 6. Okay, minus with 6i, so 6i would be 6, 0, 0, 0, 6, 0, 0, 0, 6. Okay, so what you will have here is 1 minus 6 is negative 5, 2 minus 0 is 2, 3 minus 0 is 3, 0 minus 0 is 0, 4 minus 6 is negative 2, 5 minus 0 is 5, 0 minus 0 is 0, 0 minus 0 is 0, 6 minus 6 is 0. So here is your A minus lambda 6i. Okay, so to find eigenvector, we know that A minus 6i multiplied by matrix X is equal to 0. Okay, so now you have your A minus 6i is negative 5, 2, 3, 0, negative 2, 5, 0, 0, 0, multiplied by the matrix of X. So the matrix of X is the unknown matrix. Before this, we have used our unknown is X, Y, Z. Okay, so just put it as X, Y, Z equal to 0. So 0, 0, 0 means that now we need to solve our system of linear equation. Here is our system of linear equation, and we need to find the value of X, Y, and Z. So we use the knowledge that we learned before. Okay, so the first thing you need to do is you need to write this one in the augmented matrix form. So you will have negative 5, 0, 0 here, 2, negative 2, 0 here, 3, 5, 0, and your B matrix, which is 0, 0, 0. Okay, so what you need to do is you need to reduce this one to be row echelon form. So you need to make sure this one is equal to 1. So how to make sure this one is equal to 1 is just by simply divide your row number 1 with negative 5. Okay, so it will give you the new matrices where the row number 2 and row number 3 is the same one. Okay, so you just need to change row number 1. So row number 2 and 3 will remain the same. Row number 1 will become the new one. Okay, so row number 1 divide by negative 5. Negative 5 divide negative 5 is 1. 2 divide negative 5 is negative 2 over 5. Okay, 3 divided by negative 5 will give you negative 3 over 5 here. So 0 divided by negative 5 will give you 0. Okay, so we need to make sure that the element below leading one is equal to 0. So here is already 0. So we done with the first column. Okay, next we need to make sure this one become a leading one. Therefore, we need to do operation where row number 2 is equal to row number 2 divided by negative 2, because we want that one become 1. Okay, so it will change only row number 2. Row number 1 and row number 3 will remain the same. So we just copy back. Okay, we will just only delete or change the row number 2. Okay, so 0 divided by negative 2 is 0. Negative 2 divided negative 2 will give you 1. 5 divided negative 2 will give you negative 2 over 5. And 0 divided negative 2 will give you 0. Okay, so now if you can see, we already have the, this one is not negative 2 over 5, it's negative 5 over 2. Negative 5 over 2. Okay, so now if you can see, we already have the row echelon form. So we can stop here. Okay, so if you can see here, you have the leading one here and here. Okay, and this column is belong to X, this column is belong to Y, and this column is belong to Z. Okay, therefore, the column that have leading one we call as pivot column. So this X and Y will be the pivot column, but the column Z is non-pivot column because there is no leading one inside this column. Okay, and the variable that belong to pivot column, we call it as a leading variable. So here we have our leading variable, which is X and Y, and the variable that belong to the non-pivot column is a free variable. So our free variable here is Z. So I told you before, we will let our free variable Z equal to T. Whenever you have your free variable, you will let your free variable become or equal to T. Okay, so this is the information. Okay, now from this row echelon form matrix, you need to transform it into equation. So for the first row, what you will have here is X minus 2 over 5Y minus 3 over 5Z equal to 0. For the second row, you will have Y minus 5 over 2Z equal to 0. And just now, we already let our Z equal to T. Therefore, you need to substitute your Z here equal to T. So what you have is Y equal to negative, what you have here is Y minus 5 over 2T equal to 0. So your Y is equal to 5 over 2T. Okay. Then, we need to substitute the value of Y and Z inside this equation. So what you will have here is X minus 2 over 5Y. So your Y is this one. Okay, 5 over 2T. Minus 3 over 5 times with T is equal to 0. Okay, so you have here your X minus with, this one can be cancelled out, minus with T. Okay, minus with 3 over 5t equal to 0. So negative t minus 3 over 5t, you will get x minus 8 over 5t equal to 0. So your x is equal to 8 over 5t. So now you already have the value of x, the value of y, and the value of z. So you can write your x as 8 over 5t, your y is 5 over 2t, and your z is t. This one is your eigenvector.